Hello everyone, my name is Matt Hyam and I'm going to chat a little bit in this video about a quick introduction to machine learning using an introductory machine learning algorithm called K-nearest neighbors. So a little bit about myself. I am a professor of stats and data science at St. Lawrence University. My favorite class to teach is our Foundations of Data Science course, which is a coding-heavy course that introduces a lot of really cool data science-y concepts. And my research is mostly in statistics applied to a lot of ecological problems. But enough about me. The goals of what we're going to talk about now are to first just explain what classification is and how it can be used. We also are going to go into explaining how the K-nearest neighbors algorithm works for different values of K, so we'll dive into what that really means. And we will also talk about how to evaluate some of these models using what's called a classification rate. And so getting at that first goal, what even is classification? So classification is used all the time in everyday life. Some different questions that classification can be used to answer might be, does Spotify think that I will like a particular song or not? Will a student pass or fail their driver's exam? Will a student go to a college in-state, a college out-of-state, or not go to college at all? And the one that we will be investigating in this short video is, will a particular NBA basketball player be selected for the All-Star team? One thing that you could notice is that all of these questions involve some sort of categorical variable. And so in the NBA example, either the player is selected to be on the All-Star team or they are not. And so we would say that that is a categorical variable with two levels. Either they are an All-Star or they are not an All-Star. And so to introduce this, we've got some basketball data. And I admittedly am not that big of an NBA fan, so I will probably not do so well with some of these names pronouncing them, but I'll do my best. And our data has a few different variables. It has the name of the player. It has whether or not they were selected for the All-Star team that year, which is kind of a prestigious thing. It has their average points per game for that season, and it has their turnover rate per game of that particular season as well. And so we're going to suppose that we use just 15 basketball players to train a KNN model. And we still haven't talked about what that is, but that's fine. We'll get to that in a sec. And we might want to use their points per game as the predictor in the model. And so do we think that having more points per game will be a good predictor for whether a player is selected as an all-star? I don't think you really have to be a fan of basketball to know that the answer to that question is probably yes. Probably players with more points per game are going to be more likely to be selected to be an all-star. But as we'll see with the second example, the answer to this type of question isn't always that intuitive. So what I'm going to do is I'm going to take my 15 basketball players that I have data on, and I'm going to put them all on a plot where I'm graphing their points per game, and so that's what's on this x-axis. And then I've colored their circles, so each of these little circles represents one player. I've colored them with whether or not they are an all-star, and so green is all-star, blue is not all-star. The idea here then is that using these 15 players, I can then make a prediction for, say, another set of 10 different players about whether or not these other 10 players were selected to be an all-star or not. And so how we are going to do that is we are going to use K-nearest neighbors That's the title of the talk. And we are going to set K to be 1, meaning that for each of these 10 players, again, the goal is to predict or to classify whether or not each of these 10 players is going to make the All-Star team based on our data of 15 NBA players that's shown in the plot. And so using K nearest neighbors, the algorithm is at least fairly intuitive. I'm going to look at this first player, Bates Diop. Again, not really an NBA fan, so that might not be how you say their name, but they scored 9.7 points per game on average in that season. So they are about right here where my mouse is on the plot, so just to the left of 10. And the idea here is that since we've set K to be 1, we are looking for the closest dot on this graph. Here, the closest dot is this dark blue circle. And so the idea is that I would classify Bates Diop as not an all-star, because the closest circle is blue, and blue is not an all-star. I would then repeat this to get 10 different classifications for each of these 10 players. And so to do another one, I'll do a well-known name one this time. So for Kevin Durant, he scored 29.1 points that season. So he is somewhere way over here off the chart. He's a very good high-scoring player. The closest neighbor that he has is this green dot, and the green dot is an all-star. And so the KNN algorithm with K equals 1 would say, okay, I'm going to classify Kevin Durant as an all-star. And so again, it would repeat that for all 10 of these players. So we would get 10 different classifications. But K doesn't have to be 1. And so in the second part, we'll talk more about what might make a good value of K. But for now, we're just going to talk about how the algorithm would work for different values of K. And so if K was equal to 3, again, I would get 10 different classifications. And I'm going to go through this Bates Diop player as my example. So their points per game is 9.7. That puts them right here where my mouse is. And so if we use K nearest neighbors with K equals 3 to classify these 10 NBA players into either all-star or not all-star, what the algorithm will do is it will look for the 3 nearest neighbors. And so here the closest points are this blue dot, and that green dot. And then it will say, okay, for this player, the 3 nearest neighbors include 2 blue dots and 1 green dot. Blue dot has the majority, and so it would classify them as not an all-star. For Kevin Durant, he's way over here. His 3 closest neighbors are green dot, green dot, green dot. And the algorithm would then say, all right, there are 3 green dots, 0 blue dots, so I'm going to classify him as a green dot, which is an all-star. And again, it would repeat this for all 10 players in the players that we are, in the set of players that we're trying to classify. Okay, so with that, there is a worksheet that you can get started on to practice a little bit with some of what we've discussed so far. Some questions that you'll answer on the worksheet are, do you think having more turnovers per game will be a good predictor for whether a player is selected as an all-star or not? This one I think is more interesting and maybe a little bit more surprising than the points per game predictor that we've used in this video. And then some other questions to get you thinking about how this KNN algorithm actually works.